Allen Millyard has built several different big bikes, but probably the largest one to date is built around a Viper car motor. This is a V10 car engine put into a motorcycle chassis. And Allen not only had to fabricate everything on the motorcycle, he had to then fit it into the thing and make sure it all worked. So, Allen, can you tell us a little bit about how this thing started? How did it come about?
Well, basically we bought this Dodge Viper V10 engine on eBay with the aim of making a bike similar to the Tomahawk that the Chrysler actually built, but I actually wanted to make one that was road licensed for the UK and it could be ridden on the road, so I had to make it more like a European style motorcycle.
So the first thing you bought the motor. So you had the motor sitting on the floor of this garage. How big is this space that you're working in?
Well, this is actually a large garage for a UK premises. This is 21 foot by 8, standard 17 foot by 8, so I've got an extension on the end.
So we're in a 21 foot long garage,
yeah,
with a Viper motor sitting on the floor.
Yeah, in the middle it was.
All right.
Yeah.
And what was the next thing? How did you then get this going?
I had to basically remove everything from the engine that I didn't need to run in a motorcycle, like the air conditioning pumps, power steering pumps, get it as small as I could physically get it lengthwise, because I was conscious that the bike's going to turn out long. And then when I did that...
What is the overall length of the bike now?
9 feet. Front to back.
It's 9 feet long, front to back.
Yes.
And roughly how long is the motor?
About 3.5 feet.
So it's about 3.5 feet.
Yeah.
So you probably had to take like another 2 feet of stuff off
the front. Yeah, and the back.
Just to make it fit.
Yeah. And I didn't actually want a frame. I didn't want to put the bike into a frame, the engine into a frame. So I've actually bolted the frame on the front of the engine, and bolted the frame on the back of the engine, and there's nothing that spans the engine.
So the engine is a stress member of the actual chassis
That's
itself.
Correct. Very stiff Dodge Viper engine.
You would think. So what really was the first challenge that you decided to address?
Well, the very first thing I did was getting transmission to the rear wheel, because clearly the crankshaft on a car engine runs front to back and the motorcycle wheels left to right. So I've got a 90-degree single-speed bevel box bolted as close as possible to the engine, and I made up a single-sided swinging arm to drive a rear wheel. That was the very first thing I did. I sat on its actual stands like that.
Okay, and then so the next stage, once you'd got that and you knew that was working, I mean, how do you actually run the motor at that point? Did you know that the motor worked?
No, not at that point. But I checked the compression; it was good, and I knew I was changing all the electronics, so I knew it would work.
So okay, so you've got this V10 engine. How do you keep it cool?
Well, basically, I've got the same radiator area as a Dodge Viper car. Although you may look at that radiator and think that's minute. I've got another radiator down the side behind the manifold headers with twin fans behind it. So the actual square footage of radiator surface is the same. Now, the engine on a car is inside an enclosed area, so obviously it's running in warm air. This is out in the draft, 200 mile an hour draft, so it's getting a little bit of air cooling as well. I've got no oil cooler fitted because I haven't really got space to fit one nicely, so I took a chance and didn't fit an oil cooler. But my oil temperature is running about 105 degrees at 200 miles an hour. So I'm actually well within the margins for oil temperature. The water temperature runs at about 85 to 90 degrees on a warm day. So that's cooling okay.
Wow, that's well within. That's great.
Well, one of the things
what about the exhaust? What have you done?
Well, that's one of the key factors as well. This is 2mm thick carbon steel exhaust pipe with the ceramic coated on the inside and the outside. So the heat goes out of the engine to the back. You get a higher tip temperature than normal, but it takes the heat out, which means the velocity of the gas is quicker. So it actually gives you more power as well, if I need any more power. But it's a really good coating, because when I actually first ran the engine without the coating on, these were glowing orange at idle. And it was a hazard. I mean, you had to be careful walking past it because you just catch fire as you walk past it. So I had to do something about it, and I researched the internet, and there's a company called Camco up country, and it's ceramic coated, and I must admit it's lasted for 5 years remarkably well. It's hardly tarnished at all.
And what about the silencers? I mean, these big mufflers you've got on the back.
The whole system's 3-inch from here, 3-inch straight through, right out the back. And it's got an absorption baffle about that long in the back, just to take the edge off of it. So it's technically a 3-inch straight through system with no catalytic converters.
That's absolutely amazing.
The very next thing I did was get the front wheel and make the forks so that I'd have something to offer up to the engine.
Okay.
And once I got that in its position that looked good, I made a little bracket to hold it while I built the frame.
Okay, how did you decide on the actual chassis, the rake and the trail?
I researched a couple of bikes on the internet, the Triumph Rocket 3 and I think the Yamaha VMAX, and I sort of picked a figure in between the two. Because I thought big heavy bike, it's going to be about, I can't remember what the figure is now, but it's quite a slack angle.
Yeah, it looks like it's probably like 24, 25 degrees maybe, I would think.
Yeah.
Okay. Were you at any point concerned about carrying the weight? I mean, how much does this engine weigh?
The engine's 700 pounds.
So the engine alone is 700 pounds.
Yeah.
How did you decide to build a chassis that was strong enough? How did you know that the front end wasn't just going to simply snap off like a twig?
Well, basically over-engineered it. I do know a little bit about stresses and strains and finite element analysis and all the technical stuff, but basically I have a ballpark figure in my mind of what's strong enough and what's not, and then I put double the amount in. So my forks are really thick, 2-inch thick, high tensile aluminium, aircraft grade aluminium. The front forks are 10mm thick tube, aircraft aluminium again. So in hindsight I could probably get away with half this thickness. So I've over-engineered it so that it won't break.
Right.
And it gives it a chunky look as well. Because there was no motorcycle market forks on the market that were anywhere near big enough.
Right.
They made it look small.
Do you know roughly what size these forks?
75mm.
So 75mm fork.
Yeah.
What about the internals in the forks? What did you made those from? I mean, what springs did you use?
The springs are just custom springs I had made. The bottom sliders are actually out of like digger rams, hydraulic rams, so they're very strong and hardened chrome. And the suspension damping is from a car. It's a Vauxhall Carlton insert for a front McPherson strut, which gives it the correct damping. It's only got a shock in one side, spring in both sides, and a shock only in one side.
I see. Okay.
So that's all it needs.
Okay, so then the next stage, probably after the front end, what was the next?
Well, the bodywork really. I had to create a tank that holds sufficient petrol to get to the garage and back.
Right.
And obviously how the fuel pump and all the electronics and the hydraulics.
Okay.
The whole bike really. It's not the case of doing one job, you've got to think ahead 10 steps at any one time. I always say to people it's like playing chess. You can't just do this move, you've got to think about 100 moves in front to get to the winning point. So when I'm cutting the frame, I'm thinking about everything. Where I'm going to mount transducers, where I'm going to mount hydraulic stuff, forks, wheels, tank, everything all at once.
Right.
Otherwise you end up making it 5 times. I don't do any drawings as such. I do a couple of basic, sometimes layout sketches of components, but I don't do any technical drawings or any computer aided work at all.
Right.
So it's all done from a mind's eye view.
I mean, I look at this tank, I look at all the compound curves on it and how beautifully crafted that is. Is that made from just one sheet of metal that you just hammered out?
Well, almost. The front sections are from a 1970 Kawasaki H1, which I had a badly dented tank, so I used that part there. The top bit's a flat sheet, and the side bits are quite a lot of little segments, all cut and welded in. Then once it's all welded in and cut, you linish off all the welds, turn it upside down and beat it into a leather, like full of sand, a piece of leather, in with a hammer to get the shape that you want. And that's the shape I ended up with. That's a Triumph petrol cap, recessed in.
Absolutely beautiful. So then the next section, then presumably, then you had to start worrying about the rear end of it.
Well, the rear end, yeah. I actually had it as we had no seat or no rear fin for quite a while, so I wasn't quite sure how it was going to look. So I thought I'll get on and make the exhausts. So I made the exhaust system, and I used to have a TL1000 Suzuki years ago, and the back end is like modelled like my old TL1000 Suzuki. Okay. So I like to look at that, so I've got big cans up high. And then once I did that, I suddenly realised how it was all going to fit in. So I made the superstructure for underneath the frame, and all the electronics are in the back here.
Okay. So you obviously went with a single-sided swing arm.
Yes, because I wanted to look like a motorcycle. I've seen quite a few car engine bikes on the internet, and they got 2 great girders going down to the rear wheel.
Right.
I didn't want it to look like a bike that's made with brackets and bolts. It wanted to be engineered like a motorcycle.
Okay.
So it's all fabricated out 1/4 inch thick carbon steel. The rear swing arm. It weighs 150 pounds.
The swing arm weighs 150 pounds.
Yes. It has to have there's a lot of stress in that swing arm, so it has to be with the torque from the engine. This makes 500 pounds-foot of torque.
500 foot-pounds of torque.
When you think a Hayabusa Suzuki makes about 85, it puts it in perspective, doesn't it? And that's a torquey motorcycle.
It does. Right, so the suspension now, those rear shocks look familiar.
Well, they're off in 2006 or a Yamaha R1.
So you've got R1 suspension at the rear.
Both, I've got two, I've got one each side.
Okay, so two shocks.
Extra strong springs.
Okay.
And the dampenings are set on max.
I'll bet.
Click number 20.
Do you find that those overheat with the exhaust so close to that?
I haven't had a problem with them yet. They are a little bit on the soft side. I could probably do with slightly better shocks, really, in reality.
Right.
But I've been up to 200 and odd plus miles an hour, and it handles okay up to those sort of speeds. So.
Right. Right. Now, looking at the front, I can see an astonishing front brake on there. So how did you arrive at that?
Well, it's a car-engined bike, so although it's a motorcycle, I wanted some car orientation as well. So I've actually got a car set up on the front with the wheel offset to the right and then the brakes on the left. I didn't want to put just one 6-pot caliper, so I put two running on one disc, which is a proven process. It's done on several vehicles. Aeroplanes, for instance, have 2 calipers quite often. So and that gives a 93% braking efficiency when I had it tested at our testing station.
Okay.
For the weight of the vehicle.
And then what are the wheels made from? How did you do those? Did you have to fabricate those, or are they made from something else?
The original wheels, when I first got it on the road 4 years ago, I fabricated myself by getting standard car wheels and cutting them up and welding them. But I've since had 3-piece raw aluminium split rim wheels. Because of the speed and the weight and the centrifugal forces involved at speed, I didn't want to take any risks with my cast welded wheels. So these are expensive 3-piece split rim raw aluminium wheels, anodized black, with stainless steel fixing bolts, so it all looks nice now. And I've got matching wheels back to front now, which is really good.
Right, beautiful. Instrumentation. What did you do with that? I don't recognise those clocks.
Well, they're made by Kosto in Japan. Really good system. It's completely programmable by myself. I can program it, all my sensors. I can link it to my AM Pro if I want. I can link it to anything and get all the data from the engine. So it's a really good little system. So basically, it's a big tachometer, and then it's got a speedo, and you've got trips, and just like anything else, oil pressure, water pressure, everything.
Sure. So the thing that I'm curious about is with a longitudinally mounted motor like that, when you blip the throttle, doesn't the torque reaction just want to flip the thing over sideways?
It is quite exciting and challenging to manage it, but I've got a technique now. Basically, you don't blip the throttle when it's in neutral or when you're coasting with the clutch in. But when the clutch is out, you can open the throttle as hard as you want and you get no torque reaction.
Why is that?
I don't know. It doesn't torque. Everybody thinks it's going to open the throttle and go like that.
Right.
It doesn't do it. It's absolutely just straight.
Do you think that's anything to do perhaps with the rear gearbox? Is the counter-rotating shaft?
Doesn't pull at all when you're riding it. You can roll off and open up and it's straight.
And it's absolutely
if I pull the clutch in and blip the throttle, it'll go like that.
Okay.
So you never do that.
How does the bike handle in the corners? Is it? I mean, it's obviously at 9 feet long. I don't know what the wheelbase is, but it can't be much.
It's like an oil tanker, really. But I've perfected a method now where I can do. You have to commit. It weighs half a ton, so you drop it into the corner, and you know that the power is going to bring it back up.
I see.
Whereas when I first got this on the road, I was scared to lean it over because of the weight.
I'm sure.
But now I know that I can drop it down, and my strips on my back tyres are less than 10 millimetres wide. I've been right over the edge.
So, and actually when you're in a corner, so it's relatively neutral handling.
Absolutely.
So when you're in a corner, it'll hold the line well?
If I know the corner and it's not too badly damaged, the road surface, I know that I can lean it and I can go right over. Like, for instance, going onto the motorways, the big round loops onto the motorways, I can get it right over on those. Because I know the road's smooth and I know there's no drains and potholes. Because it weighs half a ton, if you hit a pothole in a corner, it'll go like that.
Right.
Because it's a shock on the twist.
Of course.
The chassis is very stiff, but it's just the length of the weight. It's a big bike.
Sure, and obviously on the load on the suspension is
But I've ridden it around all the little twisty streets in the UK and at the Isle of Man last year at the TT races, and I was 600 miles in 4 days.
Right.
Without any problems at all. We took it out with a magazine to do some testing with top speed, and we were hitting speeds over 200 miles an hour pretty much on our first run, which was incredible. But the funniest thing about it was when we looked at the laptop, looked at the telemetry, the actual acceleration curve, we didn't have a curve. We had a straight line. And we were doing 207 miles an hour, pulling nearly 2G of acceleration forces, and a dead straight line from zero, which is unheard of. The magazine, they tested Suzuki booster turbos, all sorts of stuff, and yes, they pull fast, but they're in the curve at 200 miles an hour.
Right.
We hadn't reached it.
Is the curve is caused by aerodynamics. Essentially, you get to a point where over 150 miles an hour, where the air pressure gets stronger and stronger.
That's correct.
And you need a lot more horsepower to keep pushing you.
Yes.
So eventually, you start hitting 200 miles an hour plus. It gets really hard to break to push that air.
Yeah.
But this has got at 500 foot-pounds of torque. You hadn't got even close to that limit.
No, close on 500 horsepower as well. And it's proper horsepower. Well, I call it proper horsepower, and it's set on a dyno for 10 hours making 500 horsepower. Whereas bikes, I've seen bikes that make 500 horsepower for half a second, because they just bring it into the power and turn it off. This is brute force engineering, really.
Right.
Big CC,
Great.
8,000 CC. So
now, a standard Viper obviously has sort of big clutch and big transmission components. So how does your clutch and transmission? You don't have obviously a conventional motorcycle gearbox.
Basically, I've got a lightweight aluminium flywheel from a performance tuning shop. Got a special clutch plate, single clutch plate, and a 90-degree bevel box with 1.5 to 1 reduction ratio. So I've technically got a single-speed transmission, like a twist-and-go scooter in some respects. Except the only difference in my bike, I've got a manual clutch. I haven't got an automatic clutch, which is the general norm with big engine bikes. I wanted it to be like a motorbike with a clutch. So basically, you open the throttle up, you let the clutch out just a tiny little bit. It instantly goes up to 25 miles an hour. Let the clutch out, and then you can just ride it up to 207 miles an hour, which is what I've done so far.
Okay, so the mufflers, you've got a relatively small amount of actual silencing in there.
Yes.
So does the bike sound pretty loud?
It's got a bark.
It's got a bit of a bark.
But it's because it's never really gets on load, because it's not pulling any weight. So you have to be really going up a steep hill on a high throttle opening to get the real bark out the back.
Okay.
So, because relatively it's half a tonne compared with a 2-tonne Dodge Viper, so it's not pushing the weight.
Sure. Well, it's a V10, 500 horsepower, 500 foot-pounds. Why don't you start it up and let's hear what it sounds like.
Let's go for it.
Alan, thank you so much. That is an absolutely amazing feat of engineering. And the fact that it works and runs and goes around corners is spectacular. You have my admiration, sir.
Thank you.